how to use C# to create a numerical method called Falsi method. In the last video I showed you how to make a bisection scheme using C#. Okay, here's the regular Falsi method. Okay, sorry for not introducing myself. I'm still John Josh, or my friends call me J-Cube. That's because I'm John Joshua Jr. Pretty funny. Okay, here's it right now. Okay, zoom, scrolling down, up. Oh, okay, let's go. Then this is it. It's still the same pattern as the bisection method you can see from the last video. You notice that still the same thing that is here. They try, catch. These do just to repeat this in case the person imputes yes or no at the end. And this is a string. You all know what a string does. String captures in anything input is captured as a string unless you convert it to either an int, float, either an int or a float. This is an int, or this is a float, or a double, or a decimal, whichever one you want. So this collects the input. As you can see, float xy collects the input. What collects the input actually here is console of readline. So this float dot parse converts this input into what? Into a float. Okay, float is just like an integer, but it contains decimal places. Okay. Then this is the same story here. Your float collects the first interval, second interval, then the highest power of the equation. Then the highest power of the equation is stored in the power. Then it is now in turn stored at the length of the array. I included +1 here so as to make it show the last digit. So as to make it show the last digit. And this is here. So it goes. Because if I didn't include +1 here, if your highest power is 3, what you want to show to stop at 2, it will be 0, 1, 2. But when it's highest power is 3, when your highest power is 3, you have x cubed plus 2x squared plus 3x minus 2. You're having 4 equations there. So there are four elements in that array. So that's included +1. I didn't explain this in the first bisection video, but I'm explaining it now. Okay, now this is the same method stored in the array. Then this is the if to determine if it's negative. This double slash means comment. If you move it, it's clear. If you put it back, the comment. Then this you can zoom it. Make it bigger. Take it like this. Okay. See it. Understand? If it is negative, that means either this is positive, this is positive. Either this is positive or negative, or negative and positive is less than 0. So that means there's a rule between intervals. Okay. The major difference between regular Falsi and bisection is just this formula here. This formula is the formula for locating the midpoint of a line. You're having a line containing x1, x2, y1, y2. So this formula will locate the midpoint x0 of the line. While in bisection method you have to divide it by 2. Okay, this is the regular Falsi method once again. Okay, now this is it. Using a for loop, you assign values of your y0, which is what? Your x squared, inputting the values of your y0, which is this. So into the equation. This is how you get the equation. And this float casts this, which is a double, cast to a float. This method is called casting. Okay, then look at everything. If x is 0 and you are checking for positive, so if the product of this the midpoint value and the original function of x is less than 0, that's negative, let your x2 equals x0. So you are replacing, checking for the positive and negative. So you just want to work between positive and negative. So if you have positive, negative, you remove one positive, that's the initial positive of the x1, and put x0 and x1. So your x2 becomes your x0. So which in turns, this is a while loop. So in turns come back and do this. So at this stage now, float. This is just to round it up to 6 decimal places, because you can be having 0, 0, 0, 0, 0, different values. Okay. That's how I do it. Then and that break. Okay. Else there's no root. Else if this and this, look at from here, if this and this is not negative, if they are both positive, that is greater than 0, greater or equal to 0, that means there's no root between intervals. Then this try catch catches the error in case somebody puts an alphabet instead of a number. People can be funny, you understand? So used to try again, yes, no. So let me try this now. Okay, first interval, let me give it 0, and second interval minus 20, then highest bound equation 3, that's x cube. But what constant here is 1. There's no value with the variable x, so just 0. Then we have one variable x squared, that's what, minus 2x squared, then 1 x cube. So you look at it, there's a root between interval and the root is minus 1.6180. For that is, look at it, it's been approximated. Okay, and you should try again, yes or no? And it seems yes. Start all over again. Okay, let's try it for the other root. We have 0, 1.33. This 1.33 is the minimal point of the equation. That's the turning point, one of the turning points. Okay, highest power is 3. The value of power 0, that's a constant. Power 1 is 0 minus 2. And see the root is 1. Okay. Yeah, perhaps in the last of it we go.